We're here at the example table, and in this video we're going to look at the vector product again. In a previous video, we computed the vector product of these two vectors using determinants. In this video, we're going to look at a different approach. Let's look at the canonical unit vectors. So I, j, and k. We know that I squared, if we think of I squared as representing the vector product of I with itself, we know that I squared, j squared, and k squared are all 0. The vector product of a vector and itself is 0. Similarly, we know that ij is k. We know that jk is I, and we know that ki is j. K also equals negative ji. I is negative kj, and j is negative ik. In other words, if we flip the order of I and j to ji, we don't get k, but negative k, and likewise for jk and ki. If we keep these things in mind, we can multiply these two vectors using the ij and k notation the way we would multiply any two polynomials. So let's see how we can do that. So we'll write these vectors as 2i plus 6j minus 4k times 5i plus 3j plus 7k. We're going to multiply these as if they were just regular numbers, keeping those identities for I, j, and k in mind. So this equals, we'll multiply 2i by each of these terms first. So 2i times 5i is 10i squared. Now you might already be thinking that I squared equals 0, so this term is going to disappear. It is, but I want to write it here so we keep track of it. The next one is 2i times 3j, so this is plus 6ij. Remember, 2i comes before 3j, so we want the I before the j. Order matters. Plus 2i times 7k, which is 14ik. Now let's multiply 6j times each of these terms. This gives us 30 times ji plus 18j squared plus 42jk. Finally, we'll multiply negative 4k by each of these terms. We get negative 20ki minus 12kj minus 28k squared. Now let's get all of these in terms of I, j, and k alone. We already know that the 10i squared, the 18j squared, and the negative 28k squared disappear. So 6ij becomes 6k, 14ik becomes negative 14j. Remember, k times I is j, so I times k is negative j, so we get a negative 14j. Likewise, 30ji becomes minus 30k. And then next we get plus 42i, j times k is I, minus 20j plus 12i, and this is 0. So finally, we combine all of the i's. We get 42 plus 12, which is 54i. We'll combine all the j's. We have minus 14 and minus 20, so minus 34j, and finally minus 24k. And you'll see that this agrees with the answer we got when we used determinants.